Some time ago, an earthquake struck Kazakhstan, but investigations revealed that its epicenter was not within the country's borders. Instead, it was located in neighboring China in the Xinjiang province. This discovery sparked a flurry of activity across social networks, where people recalled that a few months earlier the Chinese had begun drilling what was touted as the world's deepest vertical well at that very location. Named Shandi Takminus 1, the project aimed to reach an unprecedented depth of 11,000 meters, a truly ambitious goal. While this seemingly unrelated fact might not initially seem connected, subsequent events unfolded like a detective story. Less than 2 months after the drill began, Kazakhstan experienced another tremor, this time with its epicenter just 30 kilometers from Almaty, near the Kyrgyzstan border. Then, almost exactly a year later, in March of 2025, a magnitude 5 earthquake struck the region again. The internet was soon rife with speculation linking these seismic events to the Chinese drilling project. Many questioned whether digging such a deep well could trigger earthquakes in distant regions. Researchers delved into the matter and uncovered compelling details. The Chinese started their super deep drilling on May 30th, 2023, in the heart of the Taklamakan Desert, one of the most barren and inhospitable places on Earth. Their plan was to reach the target depth within 457 days. Remarkably, on the 4th of March, 2024, the exact day Kazakhstan was shaken, they reached 10,000 meters depth. While it might be coincidence, the timing is striking. Adding to the intrigue, Shandi Takminus 1 is not the only deep well in the region. Chinese oil and gas company CNOOC had already drilled at least 2 other wells nearby, reaching depths of 9,472 meters and 8,590 meters, respectively. These wells became the deepest in Asia, illustrating a deliberate, methodical effort to penetrate the Earth's crust in this area. And it appears that seismic activity in neighboring countries coincides with these drilling operations. When this theory gained popularity online, journalists sought expert opinions. However, scientists could not provide a definitive answer. The question remains, could China's deep drilling have caused the earthquakes? Human efforts to induce seismic activity are far from new. For decades, man-made earthquakes have been documented worldwide, often linked to predictable causes, notably water. A well-known example comes from Denver, Colorado, where in 1962 the military decided to dispose of contaminated water by drilling a well 3,671 meters deep and pumping toxic waste into it. Within weeks, the city's ground began to tremble. Seismic activity, dozens of tremors, was recorded at depths of 4.5 to 5.5 kilometers, precisely where the waste was injected. It took 3 years to uncover the connection, after which the pumping was immediately halted. In early 1966, it seemed that the seismic problem had been resolved. Yet, the Earth continued to rumble for another 5 years as underground water traveled along tectonic faults up to 5 kilometers from a single well. This meant that drilling initiatives initiated seismic activity across extensive regions. Turning our focus to China and Kazakhstan, both nations actively drilled for oil and gas. Naturally, where hydrocarbons are extracted, large amounts of formation water accompany them. This water must be separated from the extracted liquids and disposed of, typically pumped back into the ground via specialized wells. However, this process can have surprising consequences. Research shows no evidence that the mere act of drilling causes earthquakes, indicating that drilling itself is generally safe. The real concern arises after the water is injected underground. When water is pumped deep into the Earth's crust, it triggers unusual phenomena. Imagine the crust as a multi-layered cake of rocks, separated by dormant faults that can remain inactive for millions of years. Pumping water under immense pressure into this environment alters the pressure dynamics and introduces lubrication within these faults. This process is akin to two massive stone blocks resting atop each other, locked in friction. Over millennia, they remain stable, but once water infiltrates the cracks and reduces friction, the resistance diminishes dramatically. When these giant blocks suddenly slide past each other, a seismic event occurs. A particularly insidious aspect of this process is the delay between the water injection and the resulting earthquake. Because underground water seeps gradually through tiny pores and cracks, sometimes taking months, the seismic activity can manifest weeks or even years after pumping begins. This delayed response can be confusing. People often wonder how a well drilled a year prior suddenly causes shaking long after its construction. It is worth noting that humans are responsible for several activities that consistently induce earthquakes. Scientific evidence confirms that activities such as wastewater injection, hydraulic fracturing, or fracking, to extract oil and gas, coal mining, geothermal energy projects, and the filling of large reservoirs can all trigger seismic events. For instance, filling extensive reservoirs for hydroelectric power can exert enormous pressure on underlying faults. When water saturates a valley, the added weight can activate dormant faults, leading to earthquakes of magnitude up to 6. Similar phenomena have been documented worldwide. Focusing once more on oil and gas extraction, a notable change occurred in Oklahoma, United States. Prior to 2008, the region typically experienced only 1 or 2 significant earthquakes annually. However, following the rise of high-volume water injections associated with unconventional drilling, seismic activity sharply increased, transforming the seismic landscape of the area. Earthquakes are a natural phenomenon, often occurring in the background of our surroundings, usually going unnoticed by most people. By the year 2014, the region of Oklahoma had experienced over 100 seismic events annually, more than California, renowned worldwide for its frequent tremors. What was causing this? Nothing extraordinary in itself. The surge in seismic activity was linked to the large-scale hydraulic fracturing, or fracking, happening in Oklahoma. Companies were injecting millions of gallons of water at high pressure into the ground to fracture shale and extract gas. The displaced water then had to go somewhere, so it was pumped back underground, often at greater depths. Initially, residents dismissed any connection, but later investigations revealed a direct link. The more water pumped in, the more earthquakes occurred. Oil firms denied culpability for years, until sustained legal battles led authorities to acknowledge, albeit reluctantly, that these seismic events were man-made. They even justified it with the idea that America is still a young country. In northern Russia, coal has been mined in Kuzbaz for many decades. Massive machinery excavates millions of tons of earth, and this extraction disrupts the environment's equilibrium. Removing such vast quantities of rock from one location and depositing them elsewhere shifts the pressure balance within the Earth's crust, increasing internal tension. A release is inevitable, often resulting in seismic activity. On June 19, 2013, A magnitude 6 earthquake struck near Kusbasa, close to the Bachatsky coal mine, with an intensity of 7 points on the scale. Moving across to Great Britain, a recent example emerges from the county of Surrey in the south of England, home to the oil well known as Horse Hill, nestled amid tranquil green hills. Between 2018 and 2019, this area experienced over 100 minor earthquakes annually, small magnitudes up to 4, yet enough to shake houses, rattle dishes, and crack walls. The initial official stance from the British Geological Survey was that these tremors were natural, unrelated to oil extraction. However, researchers from University College London contested this. They performed over 1 million computer simulations, concluding that the earthquakes were triggered by underground pressure changes from oil production. Surprisingly, the earthquake epicenters were located about 50 kilometers from the well, leading some experts to dismiss a connection, as they believed the influence of drilling would not extend that far. Yet, further analysis showed that pressure variations from pumping oil can propagate deep underground, disturbing faults and causing tremors. The controversy led activists to file lawsuits seeking the well's closure, which they successfully achieved in 2024. Officially, the shutdown was justified by the company's failure to properly evaluate climate risks, but everyone understood the real reason was the seismic issue. Finally, in 2017, South Korea experienced a magnitude 5.4 earthquake, highlighting that seismic activity linked to human activity is a global concern. In this country, such a scenario was truly extraordinary. Investigations revealed that the geothermal power plant was responsible, as it pumped water to 4 kilometers deep, directly above a geological fault. This process generated immense stress, causing the fault to shift and triggering a new man-made earthquake. The case of Denver became a well-known warning, often studied worldwide as a cautionary tale of engineering missteps. Following this incident, scientists began to scrutinize the problem of human-induced earthquakes more closely. They soon realized that humanity had been unintentionally causing seismic events for over a century, even before we understood the connection. In the early 20th century, as large dams and reservoirs first appeared, unusual earthquakes were recorded in regions previously free of seismic activity. Modern data confirms that during the construction of the Hoover Dam in the United States, seismic tremors increased once the reservoir was filled. Similarly, the Koyna Dam in India experienced a magnitude 6.3 earthquake that resulted in hundreds of deaths after its reservoir was filled. A few years later, the filling of China's Zaipingpu Reservoir was followed by the catastrophic magnitude 7.9 Sichuan earthquake, claiming nearly 70,000 lives. Was there a link? Scientists continue debating this question, but many believe the connection is real. Researchers from the United States Geological Survey have created a specialized map highlighting areas with heightened human-induced seismic activity. Do you know how many such regions exist? Only 8 states in the United States alone. Recall the Shandi Tak facility in Xinjiang, a site not just marked at random but situated precisely where several tectonic structures intersect. Nearby lies the Tian Shan mountain range, one of the most seismically active regions in the world. Right next to these hazardous zones, Chinese authorities have been drilling a network of deep wells, with at least 3 ultra-deep wells confirmed to be operational. These are only the ones publicly acknowledged. The true number remains classified. Data on the volume of water pumped and underground pressures is kept secret, as Chinese companies are not obliged to disclose detailed pressure measurements. This opacity prevents scientists from other nations from fully assessing the risks. Now, this situation has implications for Kazakhstan because what occurs in Xinjiang directly impacts its neighboring country. The borders are merely lines on a map. Fault lines and tectonic plates are indifferent to human boundaries. If China exerts critical pressure on the fault beneath Kazakhstan, it could trigger an earthquake anywhere along that fault line. Kazakhstan finds itself uniquely vulnerable. While its southeastern region is naturally prone to seismic activity, external influences could exacerbate this danger, placing the entire country at increased risk of a devastating quake. Earthquakes are a natural and constant occurrence in regions where tectonic plates meet, making seismic activity a regular phenomenon there. However, in recent years, seismic events have appeared in areas previously considered stable, such as the Caspian region, Tengiz, and Karachaganak fields, major oil and gas extraction sites. After the onset of intensive extraction, earthquakes with magnitudes of 4 to 5 have suddenly struck these areas, raising concerns. In central Kazakhstan's Skazgan ore zone, known for copper mining, tremors reaching up to 6 points have been recorded, while the Karaganda coal basin also experiences new seismic activity. Even at the former Semipalatinsk nuclear test site, unusual seismic patterns are being observed. These developments suggest that vast parts of Kazakhstan are exposed to seismic risks, with experts indicating that only the northernmost territories remain relatively safe. The rest of the country lies within risk zones, yet the most alarming threat looms over Almaty, one of the most geologically perilous cities on Earth. Historically, in the late 19th century, it endured a devastating earthquake in 1887 with a magnitude of 7.3, causing widespread destruction. Just 2 years later, the Chelan earthquake reached an estimated magnitude of about 8.4, one of the most powerful in the region's history. Throughout the 20th century, Almaty endured a series of significant tremors. The 1936 Kiminochoi earthquake, the 1967 Chelik quake, the 1970 Sarakamish event, and the 1971 Jambul tremor, among others. Today, the city still faces frequent seismic activity, largely due to its location atop active fault lines near mountains formed by tectonic collision. Adding to the danger, human activity exacerbates the situation. In northern China, intensive deep well drilling raises concerns about induced seismicity. In Kazakhstan's western regions, oil extraction and mineral mining are ongoing in zones already prone to earthquakes. This overlap of natural and anthropogenic seismic activity prompts a pressing question. Could Chinese deep well operations have triggered recent earthquakes in Kazakhstan? The likelihood exists, but proving it is exceedingly difficult due to limited data. Conclusive evidence requires extensive seismic monitoring, pressure measurements in wells, and long-term research. While Russian and Kazakh scientists tend to dismiss the impact of deep wells on earthquake occurrence, international experts are actively investigating man-made seismicity, citing numerous confirmed cases. They admit, however, that the potential strength of artificially induced earthquakes remains uncertain. For instance, before the Kuspas incident at Bachat, scientists believed induced earthquakes would rarely exceed magnitude 5, but the event turned out to reach approximately 6.1. Representatives from the U.S. Geological Survey stated plainly, "We cannot exclude the possibility of man-made earthquakes of magnitude 7 or higher. Such a disaster, especially near a large city, would have catastrophic consequences. Therefore, residents living in areas with heavy mining and drilling activity should stay alert, as the ground beneath their feet might be less stable than they assume, and new seismic risks could emerge unexpectedly. That essentially concludes the presentation. Should you find the content engaging, consider expressing appreciation through a like. For more insights and updates, explore our Telegram channel, which regularly features intriguing material.